Hi all. Today me and Janvi will be presenting about our project Disaster Tweet Analysis using natural language processing and machine learning. To give you all a quick overview of the project, we are trying to analyze the tweets collected during the duration of the Texas winter storm Uri. Twitter being a popular medium of communication, it holds a rich and diverse amount of data that when processed accurately gives valuable info. And since the data available is huge and ambiguous, we make use of machine learning techniques that reduce the manual effort involved. And we also classify the tweets accordingly so that it gives us insights that ensure better preparedness for future disaster. We mainly classify the tweets based on the problems faced by people such as power outage, water outage, food shortage, and injury. And we also perform exploratory data analysis for our project. And some of the visualization generated during the exploratory data analysis are as follows. The first is the word crowd. It represents the most frequently used words in a disaster. The larger the font size, the larger is the frequency of its occurrence. And we see that the most common words are those describing the weather, such as cold, freeze, ice, and snow. And the others are describing the outages, such as power, water, and electricity. The next graph shows us the location of the tweets from where they were posted, and we see the majority are from bigger cities such as Houston, Austin, and San Antonio. Moving on to the third graph, this describes the frequency of tweets during the week of the Texas winter storm from Feb 12th to Feb 18th. And we see that the number of tweets have increased during the worst affected period of the storm from Feb 16th to Feb 17th. And this fourth graph depicts the number of likes received by every category of the disaster tweets, and the maximum was received by the food shortage tweets. This means many people related or reacted to the situation of food shortage over the other issues. And moving on, the fifth graph shows the category wise distribution of the tweets, and we see most of the collected tweets talk about the power outage category. And the last graph describes about the number of tweets during the early and late hours for the power and water outage categories. And we see that in both the categories, we receive more tweets during the late hours than the early hours of the day. After performing the exploratory data analysis, we also perform sentiment analysis of the disaster tweets. We perform this using a technique called VADER, that stands for Valence Aware Dictionary for Sentiment Reasoning. This allows us to extract features from tweets and calculate sentiment scores for the data to help us classify a tweet as positive, negative, or neutral. We are using a compound score to do this, which is the sum of the positive, negative, and neutral scores, and that are normalized between -1 and +1. -1 denotes extreme negative, and +1 denotes extreme positive sentiment. Before doing the sentiment analysis, we also pre-process the tweets by removing URL links, special characters, and numbers and punctuation marks. And going ahead, these are the results obtained for performing sentiment analysis on two major categories in the data. The first graph, we see that the water outage tweets, the negative sentiment is very much higher than the positive sentiment. And in the second graph for power outage, the negative sentiment is dominating. Though the negative sentiment is dominating, we see that there's not much significant difference between the positive and the negative sentiment. And this can be due to the fact that the Texas government has executed rolling outages, which led to people getting power intermittently. So that caused them to express their gratitude for having power back. So now my friend Janvi will talk about the pre-processing and the classification techniques used in our project.
So we established in the previous slides that the data that we're trying to analyze is in form of tweets, which is human natural language in combination with platform specific characteristics like emojis, hashtags, mentions, links, etc. So we want to perform several pre-processing steps before we analyze our data. First step being removing punctuations, numbers, special characters which would not add up to any meaningful data for our analysis. In case of sentiment analysis, we also want to tokenize our data and remove stop words which would not contribute to the sentimental polarity of the text. Next, we want to normalize the tweets. Although tweets have an upper bound of characters that it can contain, it does not have a lower bound, so it is always favorable to normalize the text before processing. Now, we want to extract meaningful features that can be learned by a model from this text. Several NLTK and NLP tools are available which can represent sentences in vector format. Lastly, we have also performed label formatting wherein we have identified 10 labels that can best characterize our data set, and we have manually appended these labels to each of the data rows. Now, when we have this data ready, we want to be able to categorize the further texts into each of these 10 classes that we've identified, for which we have explored several well known classification models. The first one being decision tree. It's a supervised learning based model wherein we give importance to each of the variables and also find the splitting point at each of the nodes that we assign to. Now, this model is very good for multi-class classification and it is easy to implement. However, it can often get complex and is susceptible to overfitting. To overcome this, we take a step forward in the same direction of tree-based models and have implemented random forest model, in which we take subsets of our variables and create several different decision trees which are further combined or aggregated into a single classifier. This method of aggregation is also called as ensemble learning. Now, in tree-based methods, we separate the input space using hyper rectangles, which might not be the best way to, to encompass the data points in each of the classes. So, which is why we are using support vector machine, a kernel trick in support vector machine, which helps us to separate the data in our input space in all the classes, which might be non-linearly distributed. Now, support vector machine is a complex method. It performs really well in sparse data, wherein we have large number of variables or small number of data rows. After implementing all the three of the model, we have also calculated the evaluation matrices such as accuracy, F1, precision, recall. We on the right we also see the plot for ROC curves for each of the models. Now, it can be determined by observing the accuracy scores and the F1 scores that random forest performs the best out of each of the models. Although accuracy for SVM is better than random forest, since our data is imbalanced, ROC curve would be a best metric for model evaluation in our case. Therefore, to conclude, we have implemented classification models which can, help us visualize how Texas storm has impacted the community. We were also able to, uh, see which category was the most spoken among people and how it impacted their daily routines, and we were also able to visualize how the each of the categories progressed during the period of the storm. So we have also so finally we have used natural language processing techniques and machine learning models to extract the necessary information which was helpful for decision makers and relief providers to be better prepared for natural disasters as Texas winter storm itself. Thank you.